Alright, so I think I'm recording. I am having way more difficulty than I've ever had before with these videos and this software. It is not always recording and it stops periodically and then sometimes it won't stop. Alright, let's take a look at problem number 8. Now, wait a minute, is this the correct? Alright, so I think I'm back. I was starting to copy problem 8 from a different worksheet. So I've actually done it a couple of times with these videos crashing, and I thought, wait a minute, that's not the problem I've been doing. I've been trying to get on record here on. Alright, so I have this function g. I can look at it and I know that it is a quadratic function because I can see that it's x squared. I know that the graph of a quadratic function is a parabola, and by thinking about my function transformations, I know that the parent function is x squared. I know x squared, if a sketch has its vertex at the origin, opens upward, and looks something like this. The minus 4 is a shift to the right 4 units, so if this is x equals 4, my vertex will now be there, and it's shifted like this. I know the 6 is a vertical stretch, so the height above the x-axis is going to be stretched, so the appearance of this graph, it's going to open more narrow. This is going to open upward, and it's going to be more narrow than it was because this height, the y-coordinate of this point is now being vertically stretched, where it's now 6 times the distance that it was before. So if this were at a height of 1, now it's at a height of 6 times 1. So anyway, the effect it has, it's going to look like the parabola got skinnier, that it's not opening as wide. The plus 12 is going to take this vertex and lift it up 12 units. So let's change color. I know that a very rough sketch, because this looks terrible, is a parabola that opens upward with a vertex moving to the... See, this is in vertex form, so you can just look at it and easily see that the vertex is 4, 12. All right. Now, when we're finding the inverse, we switch the domain. Wait a minute. Let's back up. This function is not a one-to-one function because it fails the horizontal line test. So even though they asked me to determine the inverse and then determine if the inverse is a function, I don't necessarily have to do the problem in that order. I'm first answering the fact that I know this inverse will not be a function because this graph, the graph of this function fails the horizontal line test. So it is not a one-to-one function. And it's only one-to-one functions that have inverses that are functions. All right. So let's see. We now want to find the equation. Let's look at this and write the domain down. The domain of G, there's no restriction. It's all real numbers. I can see that from the graph. I can see it from the equation that there's no variable in the denominator, there's no square roots, and nobody has artificially came in here and said, hey, make it bigger than 4 because I said I want it bigger than 4. I mean, if you're the author of this function, you can do that. But this function is just a normal parabola. Fails the vertical line test. The relation, the inverse is going to be a relation, not a function. The y-coordinate at this point is 12, and if any point that we pick on the graph is going to have a y-coordinate that's bigger than 12, except at the vertex where it's equal to 12. So I know that all the y values are greater than or equal to 12. Okay, so let's erase my sketch here and begin to work on this equation to find the equation for the inverse. The idea of the inverse switches the domain and range of my function. So my new function, the domain and range have switched from my old function. So I'm also going to go back and use XY notation. I'm not going to use function notation. Alright, so domain is all real numbers and the y is greater than or equal to 12. Let's switch x and y. Everywhere we see a y, we replace it with x. Everywhere we see an x, we replace it with y. I also do that for the domain and range. It used to be that the range was y greater than or equal to 12. Well, now I have x greater than or equal to 12. And it used to be the domain was all real numbers, where now the range is all real numbers. So I know the range of this function is all real numbers. Alright. So when we look at our equation, on the right hand side I see two terms. One of the terms has the variable of interest, and that's y. I would like to solve this equation for y. I want to get y by itself. So right now it's not by itself, and there's these two terms. Well, I can move this 12 to the other side by subtracting 12. The term that has my y, I can isolate it. So I have x minus 12 is equal to this factor of 6 times this factor that has my variable of interest. So now I want to get that factor that has the y by itself. So to cancel the 6, I'm going to divide both sides of the equation by 6. 6 divided by, see, that's factors, and I can divide that. Over here, I can't do the same with the 12 and 6 because those are terms. Both the x and the 12 get divided by 6. But here, since it was a factor, well, I could choose which factor I was going to divide by 6. Alright, now I'm going to write the y minus 4 squared on the left hand side because eventually I want this to say y equals. So to get rid of the exponent 2, I need to take the square root of both sides. And when I do that, since I'm taking the square root of a variable, I'm going to introduce a plus or minus sign in front of my radical. When you take the square root of a perfect square, you just get that base, y minus 4, and that's equal to plus or minus the square root of this numerator, x minus 12, and this denominator, 6. On the left-hand side, I have two terms, and the term of interest is that variable y, so I need to get rid of the other term by adding 4 to each side of the equation. So I have y is equal to 4 plus or minus the square root of x minus 12 over 6. Now remember, I knew that this x greater than or equal to 12 and a range of all real numbers was coming along in each step. I just didn't write comma and copy it down again, comma, copy it down again. But right here I will, because this is going to be my final answer. X greater than or equal to 12. Well, that's kind of obvious, because if x were smaller than 12, like 11, 11 minus 12 is negative, and I can't take the square root of a negative number. So this is no big revelation here, and the output is all real numbers. We've seen problems where the range is restricted that I can come in and eliminate the plus or the minus. With having an equation that has plus and minus like that, I know that this is not a function. But I knew that from the beginning of the problem when the graph of my original function, when it failed the horizontal line test, I knew that this inverse was not going to be a function. Now here's one thing that I do that I don't think, maybe I should write, I don't want people to think that R is the set of real numbers. I don't like when I use inverses to use the function notation if the inverse is just a relation and not a function. What do I mean by that? The original function was g of x. So you will see people and you will see textbooks come in, and since this is an inverse, instead of using y, they will use g inverse x. But like I said, I've always thought of that as being function notation, but because this plus minus, this is not a function. So what I've always liked to do, I want to have some way to recognize that this is the inverse, is that I've always just called this, since that was y, I always just call this y inverse. So, and I know I'm working with the function g, so it's kind of like in context, I found this relation, and since the original function failed the horizontal line test, I know this relation is not a function. But it is the inverse of that original function. It's an inverse relation, not an inverse function. Well, if I use a notation like g of x there, I'm going to accidentally, I know that that's going to confuse me, so I call it y inverse. So that's my final answer. As I'm getting tired, I think I'm repeating myself quite often, and I don't know if it makes sense. So I apologize for that, and I'll try to do better the next video.